right, hope everyone had their coffee today. I'm going to go really, really fast because I only have 10 minutes. I'm talking about embedded Linux software bombs, and some Windows got in there too, so you're not totally left out. A little bit about me. I'm co-founder of Promenade Software. We're a boutique medical device software services firm. We are the software development part of some small to medium-sized manufacturers who don't have their own software teams. So we touch a lot of different manufacturers. I'm also the co-founder of MedISI, which is an information sharing analysis organization specifically targeted to small and medium-sized medical device manufacturers. Okay, so here's the goal for this talk really, really fast. It's to solve the technical problems of generating and using software bombs, not the managerial problems. If you want a good talk about that, I know Michael McNeil gives a good one. There's tons of people right here in the Cavalry who can help talk to big organizations and how they implemented it in their organization to help answer those questions. This is purely a technical talk. And because I'm from a small company and we like saving money, it's all using free tools, free as in beer, and mostly free as in labor too, but not always. Okay, so let's get some terms straight. Bill of materials. It's from the hardware world doing supply chain stuff. It's basically an ingredient list of what is in your medical device or your IoT thing or whatever have you. Software in the modern age is a magic box, magic because no one knows what's inside, running a 10-year-old OS using out-of-date third-party libraries, hard-coded credentials, that is the industry standard, and internet connection, and it can actually affect the real world. It can hurt you. Yeah, so this is why we're trying to do a software bomb. So that we take that idea of a bomb from the hardware world and make that magic box not quite so magical so we actually know what's inside of it. Why do we want to do this really fast? Customer IT likes it. This is the industry standard right now. Here's a black box, attach it to your network. Hope it's secure. Thanks, bye. It helps you keep up to date. How can you keep up to date with your third-party libraries if you don't know what third-party libraries are in your IoT device? Makes sense, right? And most importantly, your lawyers like it. When your lawyer comes to you and says, hey, what open source libraries are you using in your IoT device? Your answer better not be, I don't know, because that makes Richard Stallman angry, and your lawyers don't like it when Richard Stallman is angry, okay? So now that I've convinced you that you need one of these, how do I actually generate one? As with most technical answers, it depends. Depends on your build environment. From easiest to hardest. So the easiest way to generate a software bomb is to ask your software engineers to generate one. Anytime you use a third-party library, make sure to go to this shared drive and put you're using it with its version there. This is also the worst way because humans are lazy and error-prone, me included. It's better than nothing. If it's all you got, fine. Not really. Let's talk about some better ways of doing this, right? Ask your build system. Your build system knows every dependency's dependency, and every version number of your dependencies and their dependencies because it has to build your device. It has to build your IoT thing. It has to build your application. So any system worth its salt has a way of generating a list. I say worth its salt because if you're using C or C++, make files get a little hard. And if you have specific questions, please see me after. I have some ideas about how to make this easier for you guys. But any modernish language, C#, Node, Python, Java, here's how you can generate a list of every dependency and the dependencies that those brought in without you even knowing, and their version numbers. This will all be online on my GitHub, by the way, so you can check it out later. If you're using an embedded Linux build tool like Yocto or Buildroot, these are the two most common ones. They also specifically have ways of listing out every single package that it included and its version number. This is for legal compliance issues with open source software licenses, so the lawyers and the engineers are on the same page here for once. You can ask your OS or your package manager. You say, I'm not really using Yocto, I'm not using Buildroot, we have a consumer OS, we're using some Debian variant or something like that. Ask your package manager. They all have ways of telling you every dependency that's in there, every package in all of its versions. And this is where I said the Windows came in here. Windows even has a way of showing you, using WMIC, everything that's installed and its version number. So there's no excuse even if you're on Windows. Ask your file system. So I wish I was exaggerating when I said this, but multiple times we've had clients come to us and say, we can't ask our engineers, they quit 2 or 3 years ago. We don't have a build system anymore. All we have is this. All we have is a binary image that we flash on our device. It's got a file system on it, you can read it, but how are we supposed to generate a bomb from that? Good news in Linux, libraries all have version numbers in their file names. It's not exact. Usually it's just the major, sometimes the major and minor, but it's better than nothing, it's a good start. And if you're doing nothing right now, baby steps, okay? And kind of look forward, right? Okay, so here's the how from easiest to hardest. Ask your software engineers, ask your build system, ask your OSCO package manager, ask your file system. Try not to do this if you can avoid it. Okay, so now we have one. Yay! Our customers are happy, our lawyers are happy. What can we do that actually makes our life easier with making our devices more secure as opposed to just making people down the supply chain happy? Well, there's this cool thing called the NVD. It's a list of vulnerabilities that are known in libraries and packages and exes and stuff. And you now have a list of everything that's in your device. So let's search. Type in the first one, version number, see if anything pops up. Type in the version, second number, see if anything pops up. That gets really boring. So like any good engineer, I made a tool. Devicevulnerabilitychecker.com. You can paste your BOM in here. It supports a whole bunch of different formats. And it will give you this snazzy little output searching the NVD for different vulnerabilities based on your BOM. And this is good for more than just security reasons. This is actually something we ran on one of our medical devices that was in development. And it was the first time we ran the tool on it. And I went, Perl? We're not using Perl. Why is Perl in there? Why did Yocto bring Perl in? It turns out one of our developers had put a flag in one of their libraries that brought in some optional dependencies that we weren't using. And that brought in literally tens of megabytes of different packages. There were hundreds of packages it brought in, Perl being one of them. I went, well, just disable those flags. It reduced our file size. It increased our it increased our speed to boot, so decreased our boot time, and it made us more secure because why do we have Perl in there? We don't need it. We're not using it. And I can guarantee you any IoT system that doesn't have a software BOM has so many packages that no one's using, and they just kind of got in there somehow. Okay, so how can we automate this even more? Because I don't want to every day or every week have to type this in, copy and paste it. It's going to some server. Who knows whether I'm logging it or not? I'm telling you I'm not, but do you trust me? I don't know. Clone it on GitHub. There's a command line version. It's just Python. You can read it if you want. And one of the outputs it gives you is this XML output, this unit test output. So you can integrate it into your unit test framework that you all already have, right? Right, guys? So you take your unit test framework, you put it in here, and it fails a test if you fail an NVD, if you have a vulnerability in the NVD that's not on your whitelist, because there are false positives, of course. So here's an example off our build server of one of the first ones we did when we started implementing this. And you can see there's a lot of things that have known vulnerabilities, a lot of OpenSSL, there's Perl again, bzip, and basically this is a small list. There are false positives, and even if there aren't false positives, there are ones where you can look at it and say, well, in this scenario, it's not really exploitable, it doesn't make sense. But this is a very small list to go over, to look at it and make an informed decision, where before you were just saying, yeah, I mean, I think we're secure, I think there's no known vulnerabilities, right? So that's a huge step up. So there's Finn and bon chance. Cool. How am I on time?
Probably have time for one question. That was really fast. So does anybody have a question? And you want to get set up, Ed? Well,
where's your GitHub reference?
The question was, where's your GitHub reference?
That is a good point. I should have put it at the end. It's just Dan Beard on GitHub, and I'm going to upload it right now. Cool.
Have you taken the BOM file and tried to import it into a system to do license compliance checks against the versions?
Oh, there you are. License, like open source license checks? So, not for us, we do that manually. And we already take the output from Yocto. But there's no reason you couldn't, because it's all there. It's all in the BOM. So.
Well, they switch out. Again, I'd like to remind everybody to, if you'd like to continue the conversation, follow the presenters on purelist.com.